Okay, this is the second kinematic example for Physics 1000, Auburn University, summer 2013. So we have much the same problem as we worked in the previous example. A ball is rolling down the hill, but in this case it's different because it has an initial velocity of 5 meters per second. And what we're being asked to find is where the ball ends up. Before we were being asked to find an acceleration. In this problem we're given an acceleration, and we're being asked to determine the final position of the ball. So, first I've drawn a picture, and I'm going to stop explaining this process so explicitly. I think you're starting to see the point, but here I'm going to label everything that I know, or everything that I could possibly know. There's an initial time, there's an initial position, there's an initial velocity, and there's an acceleration. And remember from our previous discussions, I could subscript that with an I and have an initial acceleration and a final acceleration, but I know in these kinematic problems that the acceleration is constant, so subscripting in kind of makes no sense. It just makes it look a little bit more confusing, so I'm just going to call it A. And then at some time later, I've got a final time, and I've got a final position, and I've got a final velocity, and again I have an acceleration. So now I've drawn the problem to the best of my ability. I've labeled everything that I could possibly know, so now I'm going to go make a chart. So I'll do that down here. Hopefully I have enough room. So my initial time, as we've talked about, you can always make this 0 seconds. And so in the subsequent slides, I'm not even going to mess with the initial or final time. I know that my time is just going to be whatever my final time is, because all I'm doing to find my delta t is subtracting 0 from it. No biggie. And it's going to be the same thing basically with initial position, but I will include that just for the sake of it. So we've got 0 meters. And again, this is because I can set that. I always am able to set what that is. And my initial velocity, it's given in the problem as 5 meters per second. My acceleration, it's given in the problem as 2 meters per second squared. My t final, I'm sorry, that's not right. It's 7 seconds. And my x final, I don't know. Oh, I shouldn't put it there. What I'm going to do is I'm going to move over here and create another column for my unknowns. Now, I didn't label them in this problem. I probably should have. But this area here is going to be for my knowns, and this over here is going to be for my unknowns. So let me go ahead and put x final, I don't know. V final, I don't know. And acceleration I do know, and I already have that in my known column over here. So all I've done here to figure out what I know and I don't know is after I label everything on the picture that I can possibly label, I go back to the problem and I read it again, and it says, you know, it starts with an initial velocity of 5 meters per second. I'm like, aha, there's a known, I'll put that over here. And then it tells me the acceleration, there's a known there. It tells me after 7 seconds, I look at it, and there it is. And so I have all this stuff that I know, and then anything I don't know that's listed on my drawing, anything here that I don't know, I just put down here with question marks next to it. And so now what I have to do is I have to pick an equation to use, and we have 2 of them right now that are at our disposal, 2 kinematic equations. So my first one is velocity, the final velocity equals the initial velocity plus at. My second one is final position equals initial position plus initial velocity times t plus 1/2 at squared. And now, let me write that a little more clearly. I have to figure out which of these equations I need to use. In this case, it's pretty simple because what I'm being asked to find is a final position. So if you examine this equation, you see nothing in there about not only a final position, you see no positions at all. So it would probably be not wise to use this equation to solve this problem, because you're going to come up with a non-answer. So in this case, we can just right off the bat say, nope, not that guy. So we're only left with one other option now. So let's look at what we know and what we don't know, and make sure that we know everything we need to solve this problem. So what I'm being asked to find by the problem is the final position. So look here, this equation is actually already set up to find the final position. So here's my unknown, no problem. Now what I need to do now is make sure that I know everything else in there. So we'll go back to our chart and look. Do I know my x initial? Yes, I do. Do I know my initial velocity? Yes, I do. Do I know my acceleration? Yes, I do. Do I know my time? Yes, I do. So over here on what I don't know my x final, which I have in my equation, and I don't know my final velocity, but the question immediately recurs to me, do I care about the final velocity? If we look at this equation, the final velocity doesn't appear anywhere in here, so we don't care about it. We don't know it, but we don't need to know it for this problem. So that goes away. And so here I can immediately start to put in numbers, because this equation is already solved for final position, which is what I want to know. So first thing I'm going to plug in, as always, are zeros. So my x initial is 0. That guy goes away. And I come up with equals VIT plus 1/2 AT squared. Stylus is not wanting to write 2's today. So now I can come under here and say that my initial velocity 5 meters per second times 7 seconds plus 1/2, and this is 2 meters per second squared times 7 seconds. And don't forget, when you, I don't know why I wrote an S there, when you square this 7 seconds, not only do you have to square the 7, you've got to square the units also. It makes no sense for 7 seconds squared to be 49 seconds. It's 49 seconds squared. So, and at this point you plug it into your calculator returns a number, and that's your answer. But like we said in class, it's always a good idea to check yourself, and the easiest way to do that is with the units. So let's make sure that our units work out. So just moving below and working with the units, I know that I'm supposed to get a meter. I'm looking for a position, which is going to be measured in meters. So let's just see if my units work out. Here I've got a meter per second times a second, plus units over here, meters per second squared, times a second squared. And now you see the importance of squaring the seconds in this term, not just the 7. Because if you didn't square the seconds, your units would not work out. And as you can see here, the seconds are going to multiply out to 1. The second squares are going to multiply out to 1. So I'm left with a meter plus a meter, which is a meter. In units, this wouldn't be like 2m or anything. Meters plus meters are meters. Alright, so that's that. Hopefully you're starting to see the process. You guys please email me if you have any questions.